Going to be getting away from our habit of doing everything with a right triangle and start playing with some angles and angle measures that might be strange to some of you because most of you probably don't have experience with much beyond like 360 degrees when you're dealing with a circle. We can get into some very, very large angles when we're playing the trig game. So when we go to draw angles, a couple of things to keep in mind. When we do positive angles, when we're drawing them, our actual angle is going to be drawn with a counterclockwise rotation. And the direction's very important because whatever arrow direction I see is going to tell me whether it's a positive or a negative angle. So when I do the negative angle, my arrow is going to be going clockwise, like you're looking up at the minute or the second hand going around on the clock up there. So when I'm trying to draw these, there's a little bit of vocab that would be good to know. One of the parts is going to be, we're always going to have an initial side that starts here on the positive side of the x-axis. So wherever my angle starts, it's always going to start here, whether it's negative or whether it's positive. And wherever that angle happens to end is going to be called my terminal side. And so when I find that degree measure, I draw a ray coming out from the origin, and then I draw an arrow that connects my initial side to my terminal side. And that's what I'm going to be doing. So what we're going to do on this first one is we're going to kind of repeat what's over here with this 210 degree angle. So here's how this is going to work. At the start most of the time, and you'll get used to this afterwards, you won't need to do this, but I like to do it at the start. I typically will label my axes because if you think about it, every axis you go to makes a right angle. So you've got 90 degrees. So every time I pass one of them, it's another 90 degrees that I'm adding in. Because you think about your protractor, you're like, okay, well it goes from 0 to 180. Well, that doesn't completely help me here when I have a 210 degree angle. So here's what we're going to do. Typically, I'll start on my initial side, and I'll start working my way around quadrant by quadrant until I get to one and I go, wait a minute. Okay, I'm at 180 degrees right now. If I go all the way to the next one, it's 270. That's too much. How much more of a degree measure do I need from 180 to get to 210? 30. So here's how I'm going to get that last 30. So we're all doing it the same way. It doesn't get confusing. Whichever axis I stopped on, so I stopped on the x-axis this time, and I realized this last part of my angle is going to be below it, I'm going to take my protractor and this little circle that I've got working here with the dot in the middle, I want to line that up with the origin each time. So I'm going to line that up. It matches up nice with my x-axis. Bless you. And then what I'm going to do is on the inner parts of these.
Did you get the thing out of the charger? Sorry.
Oh, it's okay. So what we're going to do is we're going to find that 30. Now, I know it's tricky because unlike a real protractor, there's not like a hole in here. So normally what I'll do is I'll just hover my writing utensil over that 30 that I need, do a little magic act, slip out the protractor from underneath, and then just use my handy dandy new ruler that I have, the edge of my protractor, to get that drawn in and finish my angle by putting my arrow on there showing I was going counterclockwise. Got my angle drawn. Looks pretty similar to the one over here. I'm feeling good about this. But that's the biggest thing with these is figuring out when you're trying to get that last little piece in, how do I move the protractor around so I'm getting the right answer? So with any of these, they're all going to work that way. And again, a lot of you will get used to these pretty quickly. And to make mention, I'll make mention of it here before we even get to number 3. If you go in a complete rotation, which you know is 360, and you keep going, you just keep adding 90 to the prior one that you did. So I could add 360, 450, 540, and it can go round and round and round. It's kind of strange. So I see 305, and I say, okay, so I'm starting at 0. I got 90, 180, 270, and then I stop for a second. If I go to the next one, that's 360. That's too much. How much more of a degree angle do I need to get from here, my 270, to 305? 35. Notice this time, though, where did I stop? I stopped on the y-axis. And my angle's going to be to the right of it. So I'm going to line up my protractor with the y-axis. And I'm going to get the extra 35 that I need counting along in here. Now, it might be a little tricky. And I'm not going to be so awful when it comes to like a quiz or a test that if it's like a degree off, I'm going to be like, oh, no, it's like 10 degrees off. Okay, that's a little different. But and I do need an arrow on the end of my curve that I'm drawing to signify which direction I'm going. And also I need this to be a ray. Okay, so I'm going to have arrows on the ends of both of those. We're in good shape. Then some of the weird ones start to come. You're like 580. Again, never even knew I could go above 360. And I am a proponent, like I said before, of labeling these. And you'll notice when I started to do the one angle measures in red, they're basically just 360 degrees more than the initial ones when I went around the first time. So you're like, okay, this is kind of strange. 580. Now, how are you going to do this with lots of curves? So I start at the beginning and I say, okay, so I got 90, 180, 270. When I get to 360, don't make it a complete circle. We're making like a curly Q here. 360, 450, 540. And then I got to think. Because if I go to the next one, 630, it's too much. I need another 40. So again, I stopped at the x-axis. So that's what I'm going to line up my protractor with, and it's below that. So I'm going to get lined up here, and I need another 40, and anywhere along this line would be that 40 degrees that I need. So anytime you see a curl that goes around more than one rotation, you know, okay, it's over 360 degrees, because for each full rotation, I'm adding another 360. So just imagine if you got like a 2,000 degree angle, how many times you're going to be going round and round and round and round. You've got to really keep track of how many times you go. I'm going to pass number 4 for right now, because that's pretty straightforward with what we've been doing. I want to get to the negative stuff. So number 5, negative 450, reminder, to signify a negative, we are going clockwise now. So what does that mean? That means now, instead of the 90 being up here, I'm going to go from 0 to negative 90 to negative 180, and it basically just switches them around. That's the biggest thing to remember. Because once you remember that, then it's like, oh yeah, now I just got to follow the numbers and I'll get there. I'm still going to start my same initial side, the positive side of the x-axis. So now we're just going to go clockwise. So negative 90, negative 180, negative 270, negative 360. Hey, this one's going to end in an axis. Negative 450. That can happen. If it ends in an axis, we'll just use the axis as our ray. And I'm good to go. So as long as I can keep reminding myself, if it's negative, I'm going to do that. That's okay. Now, will you get to a point that you maybe don't even have to start labeling the edges? Maybe. Maybe just counting works. I don't know. Let's try. So I start at 0, so let's see. Negative 90. Negative 180, negative 270, negative 360, negative 450, negative 540. Maybe I'll mark that down so I remember. And I need 20 more. Same idea. Stopped on the y, not the y, stopped on the x-axis this time. And I need 20 more degrees. But that degree measure is going to be above the x-axis. So So there I am. Here's my 20. Finish that off with my arrow and we're good to go. Okay, so the drawing of angles, not real bad, just takes a little bit of practice. Get to play with the protractor some, nothing too shabby. But we're always not going to need to draw angles to be able to come up with some of the information that we need. So here's our next little piece of the puzzle. More vocabulary. Find an angle with a positive measure and an angle with a negative measure that are coterminal with 250. In other words, we're going to have two angles that have the same ending spot, the same ending ray. It just depends on how many rotations there are. And instead of drawing it, we're just going to take the angle that's given, and we're going to add 360 degrees for a positive, and we're going to subtract it for a negative. But I want to make a note here. For your positive coterminal, your angle must be positive. And you're like, wait a minute, what do you mean your angle must be positive? Of course it's going to be positive. It says positive right there. Right, but if you got like a negative 400 degree angle to start with, if you add 360, you'd still be in the negatives. So sometimes you may have to add 360 more than once. Or to get a negative, your angle must be negative. You may have to subtract 360 more than once. So just that little thing to kind of keep in the back of your mind if it happens to occur. So with these, otherwise it's pretty simple. For my 65 degree angle, I'm just going to add 360 degrees to it. So my positive coterminal angle would be 425. If I were to draw both of those, they would have the same terminal side. That's all we're saying basically. If I do 65 minus 360, I get a negative 295 degree angle, which would have the same terminal side as the other two. They'd all have the same ending if I drew them. So you're like, okay, this ain't bad. So like if I'm doing this guy, add 360, gotcha, minus 360, gotcha. Okay, this ain't bad. You're going to give us all to them that easy? With degrees, they typically will be that straightforward and easy. We'll get to a point, though, where we're dealing with radians where it gets a little more interesting. Nothing too terrible, though. And as I said before, we will be spending some more time as we move along the unit working with what's called the unit circle up here. We will get to a point where we'll have you guys memorizing what degree measures and what radian measures go together. Not yet, though. For right now, our main focus is going to be this little piece down here. Pi radians and 180 degrees are one and the same. So if you ever see pi on something, it's like saying it's 180 degrees if you ever wanted to substitute or find a degree measure. So we need to be able to go back and forth between degree measures and radian measures, depending on what's asked for within a problem. There are some formulas that only take radian measures, so I need to be able to make this conversion. So whenever I'm trying to go from degrees to radians, I'm going to multiply by pi over 180, because we said before, pi and 180 are the same thing, so it's like multiplying by 1. Except I'm just going to multiply straight across here, and then I'm going to reduce the fraction that's left. But when you're reducing, leave the pi alone. Just reduce the 18 over 180, which in this case would be 1/10. So I just have pi over 10. Or if you wanted to put a 1 in front of the pi, you could. But that would be my degree measure. And it makes sense when you think about it, because if pi equals 180, 180 divided by 10 is 18. So they're one and the same. And that's going to be the same for all of these. I'm always just going to multiply by pi over 180. multiply across, and reduce the coefficient part, leaving pi alone. So if you lose pi somehow you've lost your radians. Negatives, same thing. Never going to change. Just pi over 180. And you may even get to a point, if some of you aren't already, that just doing a little math enter with negative 72 over 180 might not be a bad idea. Because sometimes we'll actually even get coefficients up there. And sometimes they can get big and crazy. So don't think just because you're getting a really weird type of fraction that you're doing something wrong necessarily. And then, of course, we want to be able to go the opposite way too. Sometimes we want to talk about something in its degree measure instead, and it's in radians. Now, there's two ways you can look at this. There's either, of course, a mathematical formula way, where if I multiply by 180 over pi, the pi's just cancel, and I multiply and get the answer. But I've had a lot of people say, well, if pi is 180, why don't I just substitute 180 in for pi and get the answer? You absolutely can. So like here, 5 times 180 would be 900, divided by 2 is 450, and I've got my degree measure. Now, if you ever get to 1 and the numbers are starting to get a little bigger, kind of play with it a little bit. Like here, maybe you want to go back to going the other way. I don't care. So I end up with, what, negative 1620 over 2. So I get a really big angle. That'd be fun to draw. But that's all we're doing with this. So we want pi in the numerator if we want to get to radians, pi in the denominator, or just substitute it if we want to get to degrees. But then the fun part comes. And I need to start stressing this right away so there is no confusion later. You're like, these directions look similar to what we've already seen. Yes, we did this with degrees on the front sheet. A positive and a negative coterminal. Now we said on the front that coterminal was adding or subtracting 360 degrees, which is true. But now we're in radians. 360 degrees is 2 pi. So now we're going to be adding or subtracting 2 pi depending on if we want a positive or a negative coterminal angle. I've had people say, well, can I just put it into degrees? Sure, but then you got to put it back in radians at the end. If your problem starts in radians, it needs to end in radians. If it starts in degrees, it needs to end in degrees, unless you're told to do otherwise. So if I've got 2 pi over 5, and I want to add 2 pi to this. Okay, so I got 2 pi over 5, and I want to add 2 pi, or 2 pi over 1 if you want to look at it as a fraction. Oops, I don't have a common denominator yet. Let's do a quick fix for this, and this will work every time. All you have to do to get your common denominator, so you can add these, whatever the denominator of your fraction is, multiply it by 2 pi. 5 times 2 pi will be 10 pi over 5. Because 10 divided by 5 is 2. It's an equivalent, but it's a really quick way for me to be able to get to the answer. And I end in radians, and I'm good. And once I know it for the first one, I know it for them both. So I'm just going to minus the 10 pi over 5 in the next one. 2 minus 10 is negative 8. Happy camper. So anytime that you're doing these, just keep reminding yourself of that little trick. So here, for instance, my denominator is 6. To get what I add, if I want to add 2 pi, 6 times 2 is 12 pi over 6. And then just add them up. But again, under no circumstances do I start with 5 pi over 6 and end up with something in degrees. Can't do it, can't do it, can't do it. Radians is the love language of trig. You must speak the language. So, Now, trig is multilingual. It's okay, but it really prefers the Radian language. So that's how we're going to keep that going, and we're going to keep everybody happy. But again, I've got to build those fractions. I've got to have a common denominator. I can't just add across with unlike denominators and say, woo, I'm okay, because you're not. Then our last thing we're going to do with this today, as we keep kind of growing our way up into big person trig, one last flip. Got a formula to play with called arc length. Now, today we're just going to do arc length. We'll get into area of a sector later. But arc length, I like to make a comparison with arc length to, like if when you're eating a pie, that crust on the outside. That's what we're trying to find. So we're trying to find the crust of the pie with arc length. So to do this, you multiply the radius times the degree measure. Note, degree measure always must be in radian form. If they give it to you in degrees, you need to turn it into radians, then you can use it in the formula. Because if you try to use degrees, it's not going to work. So luckily, it looks like they gave us ones that we're going to be able to just use. So to find the arc length, I'm going to multiply the radius times my angle measure. And sometimes I'll even put a 1 underneath 3.5 just to make sure when I multiply across, I'm okay. Here, you're like, that's not going to come out nice. 3.5 divided by 2 is like 1.75. That's okay. Here it's saying round to the nearest tenth. Here's what we mean by this. 1.75 pi. Let's pop the calculator up. When we're asked to go to the nearest tenth, it doesn't mean 1.8 pi. It means 1.75 times, and I think everybody's got a pi button at this point. We've got one. It's second and the caret button here. So if I'm going to the nearest tenth, looks like we're heading to 5.5 here. And that's all we're going to do on any of these. 4.25, 3 pi over 2. So what I've got, 12.75 pi divided by 2. Ooh, straight whole number. 20. But that's what I'm attempting to do with these. But always reduce and always look for directions to see if they're telling you the nearest tenth, the nearest whole, the nearest hundredth, whatever it happens to be. So then, of course, we must have story problems. Every day. It's like your vegetables. They're good for you. Sometimes you don't like them very much, though. So, all right. Find both the degree and radian measures of the angle through which the hour hand on a clock rotates from 5 a.m. to 10 p.m. Okay, let's think about this for a minute. Sometimes drawing a picture can be of great help. I'll go into greater detail with that when we get to number 25. So I think about a typical clock, and I got to pay attention to little words like the hour hand. So like, for instance, right now the hour hand's at about 1 o'clock. Once it gets past this hour, how many hours is it going to take for that hour hand to be back at 1? 12 hours. Okay, so one full rotation of that hour hand is going to take 12 hours. Now, if they just said minute hand, it would have been 1 hour because it gets around to the same place every hour. So I'm like, okay, so any circular clock, how many degrees is a full rotation? 360. So 360 degrees divided by 12 hours tells me that I'm rotating 30 degrees an hour. So then all I have to do now is say, okay, if I'm rotating 30 degrees an hour, how many hours is it from 5 a.m. to 10 p.m.? What? 17. I'm with you. Because it'd be 12 hours from 5 a.m. to 5 p.m. and then 5 more. Now, there's one thing I'm going to warn you of here. Let's think about this for a second. This is a clock. Most of the time, when you look at a clock, the hands are moving clockwise. So is my angle measure positive or negative? Negative. Little details. And then it also says to put it in radian measure. So I've got 510 degrees, negative 510 that is, times pi over 180. And again, if you haven't been, just to get you a physical example here, again, just take the coefficients and reduce that part as far as you can. And that will get you your radian mode of the exact same measurement. So always watch for the little stuff. And then the doozy, and I'm going to be completely honest with you here. Even being the teacher guy, I swear, the first time I did this problem, it took me like 40 minutes till I did a smart thing. I kept trying to do everything with formulas, and then I decided, you know what, maybe I should draw a picture. So I started to draw a picture, and all of a sudden it just like clicked. It's like, amazing how that can work sometimes. So I've got a truck that has a 16-inch radius wheel. Okay. That's driven 77 feet per second. Now I noticed right away, my big thing here, I got one part in inches and one part in feet. So I decided I was going to do everything in inches. You could have gone the same way and done the same thing in feet, but I just decided to go this way. So I'm like, okay, so 77 feet times 12 inches per foot, gets rid of my feet, tells me, okay, this wheel is going 924 inches a second. That's going to be important in a minute. So then I thought a little more, and I'm like, okay, so this wheel's running. So it's going in a full rotation. And I'm like, well, wait, if it's a full rotation, I should know how far it is all the way around the circle, which is circumference, which is 2 pi r. Oh, I got to remember that stuff from geometry last year. Yeah. So my radius is 16. So 2 times pi times 16 is 32 pi. For right now, I'll leave my pi. We'll see if that helps me out in a minute here. So then I go, okay, so that's how far it goes. That's how far this is. So if I take 924 and divide it by 32 pi. Now here's the other interesting you find out with calculators. You have to be very careful. Let me show you what I did the first time. See, I'm hoping my errors will help some of you not to make the same ones. Typed it in like this. Got 90, and I'm looking at that and I'm going, that makes no sense whatsoever. What's going on? Oh yeah, order of operations. The calculator did 924 divided by 32, and then times it by pi. That's not what I want. I want 924 divided by 32 pi. I've got to let the calculator know I want 32 pi in the denominator, and the only way it's going to know is if I put it in parentheses. That's better. So it's like 9.19 full rotations. You're like, are we done yet? No. So now I know how many times the wheel's going to go around. A little over 9. Almost done. When a tire or anything circular goes a full rotation, how many degrees is it? 360. So 9.19 times 360 degrees per rotation will tell me how many degrees this guy is going to go around in this time period. And yes, like I've said before, the numbers can get ridiculous. Just be thankful you don't have to draw it. So like 3,308 degrees per second that tire's going. I can't even make my arm go that fast. So then, they're like, then? What do you mean then? Nearest degree and nearest radian. One more part. 3308 times pi over 180, because I want this sucker in. Now let's see if this one comes out nice for me. I don't think this one's going to come out pretty. Yee. 827 pi over 45. Or, if they ever asked you, because it says to the nearest, you could go ahead, do that, and multiply it times pi. I think either of those is acceptable. If you keep the pi, you're showing me it's in radians. But if you actually want to multiply 827 times pi over 45, you can actually get a value for it and have your answer. So again, the biggest thing with all of these is play with it. Keep trying things. Try something that's near it that's an odd so you can check an answer, something like that. So the back of your packet is the actual assignment for this. So this jumps us head over heels ahead, and I'm really bad on the backboard right now because we're up to what? Homework check 10 number 2, and I'm not even writing things. That's terrible. So we're on, this will be on the back here. I'll write it, that way I can't forget either. Homework check 10 number 2, because number 1 was the 13.1 bookwork that went with the notes yesterday. So we'll have that tonight. Tomorrow we'll play with some more angles and things like that, and then we'll get you to a nice, easy going break here.